Hello everyone. I am Shri again with a new video, which is EDA Exploratory Data Analysis. Without any wasting time, let's get started with the video. First of all, what is EDA? Exploratory Data Analysis involves analyzing and visualizing data to understand its key characteristics, uncover patterns, and identify relationships between variables and exploring record sets. To apprehend their predominant traits, discover patterns, locate outliers, and identify relationships between variables. Basically, EDA will help us to know the relationship between more than one variable, or maybe for the single variable too. It's their characteristics, their traits, their patterns in the data sets, and if there is outlier, they'll detect that. They'll also help us in the processing task. So EDA is also a very important step in our data science, and it is very a crucial topic as well. So basically, EDA is also a preliminary step which we perform before the data sets is going to the models for the training. So why exploratory data analysis is important? First of all, understanding the data structures. Data analysis help us understanding in the data structures, and it is very important for identifying the relationship between different variables, how they are structured, what are the similarities, what the pattern they are having. So yes, then we have the identifying patterns and relationships. Definitely, uh, majorly in the studies, the searches, and the for the businesses, patterns identification is a very crucial step, and the relationship. For example, if production of particular item is more or less, if we want to increase the stock, we should do or not. So this all things can be answered with the pattern identification very easily. Then we are detecting anomalies and outliers. If we have more than duplicate data, if we have redundant data, if we have outliers, ED help us to solve that. Testing assumption. If we have assumed something to test whether it is true or not, which can also be done by EDA. Then the feature selection and the feature engineering, it also helps EDA in it. Then we have optimizing model design and facilitating data cleaning. I have said that EDA helps in the data preparations. So data cleaning is also its part. We have understood at the previous video. Then we have types of exploratory data analysis. We have three types of EDA, which is first is univariate, bivariate, and multivariate. Univariate is basically focused on a single variable to understand its internal structure. It is primarily concerned with describing the data and finding patterns existing in a single feature. This sort of evaluation makes a specialty of analyzing characters variables inside the record set. Basically, in univariate, we will just focus on a single variable, its pattern, its relationships, and it is very kind of a basic and simple analysis. Then we have a bivariate. It is similar to univariate. It's just having the two variables in it, and it also provide us the find association between them, their correlation, their dependency between each other, and they are definitely a crucial part of EDA because they also determine the relationship between that variables. Then we have the multivariate analysis. Multivariate analysis examines the again relationship. It is having the two or more variables in it and is aimed to understand the variable interact with another variable. So basically, the relationship between the variables into the data sets. Then in multivariate, we have a special technique which is PCA, Principal Component Analysis. It is helps in the dimensionality reduction in the large data set. It is one of the important aspect because if we are working on a large data sets, for example, we have 3000 features or 3 lakh features in it, we cannot do it manually. We need something to just be precise with the data. That's why we have the feature engineering, because it only picks the important features that will be beneficial for our data sets and models. So PCA is one of the technique in which the variance will be the maximum, and it is also asked in the Shaligram Sir's demo quiz as well. Then let's see the constructing a bar graph with overlay. Basically, bar graph is used to display categorical data showing the counts or frequencies for each category. Overlaying involves adding additional series on top of the bar graph, which helps compare the distribution across groups visually. Basically, bar graph, as you have seen, the it represents the categorical data, which shows the frequency of it, and the overlay means the additional information for the comparison to it. In the snippet, you can see we have the sample data, the categories, group 1 and group 2. Then we have used the NumPy library here, in which we have stored the length of categories. So we will have in x is 0, 1, 2, because the total length of the category is 3, but we are arranging as a range, means the range. So 0, 1, 2, because the Python starts from the zero based indexing. Then we are having the bar graph with overlays, in which PLT here is the Matplotlib pyplot, which is the short form of the PLT here. Dot bar means we are representing the bar graph, and then we are passing the parameters inside it. The first is x minus zero point 0.2, which means the value of x, but zero point 0.2 slightly lesser. Then we are mentioning the group 1 width of the bar, then labeling it and specifying the color. Similarly with the group 2, then we have the X label, which will show the X heading, X axis heading. Then we have Y label, which will show the Y axis heading. We have the title. Then the title will show the entire graph's title. Then we have the legend and the show. Now let's see this in our code editor as well. The how it will visually look.